Hello everyone. Plan for this recording is to talk through the Unit 2 review worksheet. Probably this is part 1 of 2, just because the review is pretty long and it takes a while to talk through them, but we'll see how it goes. First step, we are going to graph parabolas, graph some quadratics, and find the vertex and intercepts. So first thing is to look at the equation and recognize what form it's in. Question A is in standard form. I can't look at that and see the vertex. Okay? So in order to find the vertex, because remember my key point in graphing quadratics is to know the vertex. And if I know the vertex, I can use my pattern to graph the rest of the points. So my vertex, in this case, I find by doing our little trick equation, negative b over 2a, the first part of the quadratic formula. So negative b gives me a negative 4 over 2 times a, and a is 1. So my x-coordinate of the vertex is a negative 2. If I know the x-coordinate, how do I find the y-coordinate? I plug it in. So y equals negative 2 squared plus 4 times a negative 2 minus 5. Negative 2 squared is 4, minus 8 minus 5 gives me a negative 9. The y-coordinate is a negative 9. The x-coordinate is a negative 2. Sorry, when I printed to my smartboard, my graph is off, or it's just kind of not very good resolution. That's all right. Next step. What is my pattern? What is the shape of this graph compared to my original y equals x squared? Remember we talked about y being x squared is nothing fancy. Whatever x is, you square it, and you get y because y is x squared. So if I go over 1, 1 squared is 1. If I go over 2, 2 squared is 4. 3 squared is 9. Is this equation's graph going to have the same shape or something different? The same pattern or something different? How do I know? The number in front of the x squared. If it's just a 1, just like that one is a 1, they'll have the same shape. So from my vertex, I go over 1 and up 1. If I go over 2, I go up 4. Why? Because 2 squared is 4. If I go over 3, I go up 9. Why? Because 3 squared is 9. Over 4 and up 16. Since my vertex was so low, I get lots of points. And there's my parabola. Did I need that many points? Well, yeah, why not? It's nice to have a bunch of points. A lot of times we can't get all the way to 16, but that time we can. And just make it as smooth as you can. All right. There's my vertex and my graph. Do I know the x-intercepts? Well, yeah, I happen to, because it happened to hit right at positive 1, and it happened to hit right at a negative 5. What if it didn't? What if my graph hit the graph hit the x-axis not on a whole number, or not on an integer? Well, what is the value for y at the x-intercept? 0. And so I go back to my solving techniques, and I solve that thing using one of my techniques. I'm going to try factoring that. Factors of 5 that will subtract give me 4. 5 and 1. I need a positive 4, so I need a positive 5 and negative 1. What makes each factor 0? Well, 1 makes that factor 0, and a negative 5 makes that factor 0, and we end up getting the exact same x-intercepts as our graph, which is a good thing. All right, there's graphing a quadratic in standard form. Let's graph one in vertex form. You should be able to look at that equation and see the vertex. My vertex is a positive 3, positive 4. Remember, it's x minus h squared, and so if x is, or if h is positive, then it'll be x minus that number. And if x is negative, it'll be x plus that number. It's really the opposite of what the sign is that you see. All right, what does this thing do right here? It makes my graph open upside down. Same pattern, just upside down. So I still go over 1, but now I go down 1. I still go over 2, but now I go down 2. I still go over 3, but now I go down 9. In both directions. Okay, so over 1, down 2, over 2, down 4, 3, 9. Whatever you do to the x, you square it, and that's what you do in the y direction. All right, in this case, I can still see the x-intercepts just like in the other problem, but what if I couldn't? How do I solve that equation for when y is 0? Because, right, the same is true as the other question. When y is 0, that's my x-intercepts. Remember, one of the techniques is taking square roots. So get the x squared term by itself. So I'm going to subtract 4. Going to divide by a negative. Going to square root. And when I square root 4, I generate both the plus and the minus of that. Add 3. And so 3 plus 2 is 5. 5, not 2. So 3 plus 2 is 5. 3 minus 2 is 1. And I get the exact same answers as we had before. Okay. That's good on that. Number 2. What is the discriminant, and what does it tell us about the number of solutions and the type of solutions? First thing, what is my discriminant? The discriminant, remember, is b squared minus 4ac. Where'd that come from? It's the part underneath the square root in my quadratic formula. So b squared, a negative 5 times a negative 5 is 25. Minus 4 times a is 2, times c, which is 6. And so I get 25 minus 4 times 2 is 8, and 8 times 6 is 48, and so I get a negative 23. Remember my form or my table I made before? If you have a negative discriminant, then you have 2 imaginary, spelled correctly, imaginary solutions. How many solutions are there? 2. What's the type of solutions? Imaginary. What are the other options? There could be 2 real solutions, or you could have 1 real solution. That's my other options. If your discriminant is less than 0, they're imaginary. If my discriminant is greater than 0, they're real. And if my discriminant is 0, there's 1. Those are my options. All right. Number 3. Find the equation of a quadratic function that has the given solutions. Let me do another one. I got to throw a c out here just for fun of it. X equals 2 and 3. If I know that x equals 2 and 3 are zeros, what are my factors? X minus 2 and x minus 3, going backward from what we did up in question 1. So now what? I FOIL that out. X squared minus 3x minus 2x plus 6 gives me x squared minus 5x plus 6. Okay? Pretty straightforward, but I didn't put a nice straightforward one on here. Let's do a harder one, letter A. If I use that same logic, I would have y equals x minus that big mess, and I would have x plus that big mess. No, I wouldn't. Wow. I can't believe I just said that. Hopefully you caught me. I would have x minus 3 minus that. There we go. Because I have 3 plus 2i and 3 minus 2i. I don't want to multiply that out. That would be a mess. So remember our trick we did? We multiplied both sides by 3. Goal being trying to get the imaginary part, or if we have an irrational part like question B, trying to get that all by itself. So my first step was to get rid of the fraction, so I multiplied both sides by 3, and that went away. And I times that side by 3. And then I'm going to subtract 3. And now I'm going to square both sides. Why? Because an I squared is a negative 1, and it will go away, and I have a nice, neat equation. So 3x minus 3 times 3x minus 3 is what I have on the left-hand side. And on the right-hand side, I have 2i times 2i. Doesn't matter if it's positive or negative, because they're going to cancel. And 2i times 2i is 4i squared. Left-hand side, we have 9x squared minus 9x minus 9x plus 9. Wow, lots of 9s. Now we have 9x squared minus 18x plus 9 equals, I squared is a negative 1, right? So this becomes a negative 4. Let's just skip a step. And a negative 4 moved to the other side gives me a positive 4, which is 13, and that equals my equation. All right. Question B. Remember question A, what the process or the thought process was, what the first goal is. Isolate the I, the imaginary part, or the irrational part, like the square root of 5. Done. It's isolated. Square both sides. Right? X squared equals 5, because you get plus and minus. So x squared minus 5 equals 0 or equals y. Wasn't so bad. All right. Number 4. Solve. What technique do you want to use to solve? We could factor it. We could complete the square. But what I would recommend, I notice there is just one x and it's inside a squared term. So my thought is to isolate that squared term and just take square roots. Can't do that if there's an x squared and an x, but I can here. So I have 3, 2x minus 1 equals 36. Divide by 3, 2x minus 1 squared equals 12. Take the square root of both sides. So 2x minus 1 equals plus and minus the square root of 12. Add 1, and I get 2x equals 1 plus or minus the square root of 12. Divide, and x equals 1 plus or minus the square root of 12 all over 2. 12 breaks down into 4 and 3, and so I get x equals 1 plus and minus 2 square roots of 3 all over 2. Now, we could leave it like that. That'd be totally acceptable. But I also could split it and put the 2 with the 1 and the 2 with the 2, and they would cancel, and I would get that. Either one is totally acceptable, and you see them written both ways. All right, letter B. Not like letter A. It has both an x squared and an x, so I can't just isolate the x the way it's written. So my options, I could complete the square to make it look like A. I could quadratic formula it, or I could try to factor it. Looking at those numbers, I don't think that's going to factor. So I'm going to jump right to quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Notice, when I do this, most of the time I try to do some of the work in my head because it takes care of some of the chances of multiplying wrong on the calculator or squaring wrong on the calculator. Remember, we talked about this number here can never be negative because a positive squared is positive and a negative squared is negative. If you ever get a negative there from your calculator, you did something, you typed something in wrong, and what it is you typed in was that. And that is not right. It has to be that. All right. I'm going to grab a calculator, though, to do the inside. So we get 64 minus 4 times 4 times 19. So inside I get a negative 240. So I have 8. We'll go the same color. I have 8 plus or minus the square root of a negative 240 all over 8. What perfect square goes into 240? Well, 16 does. So I get 8 plus or minus the square root of a negative 1, the square root of 16, and the square root of 15, because 16 times 15 is 240. 8 stays 8. Square root of negative 1 is I. Square root of 16 is 4, so that's 4i. That reduces down. 4 goes into all of them. That's 1i. I don't need the 1 part. So I have 2 plus or minus I square root of 15 all over 2. All right, I got a lot of stuff going on the sides. Let's get rid of some of this. All right, question C. First step, I need to get everything equal to 0. So let's go 2x cubed plus 2x, minus 10x squared equals, plus, at least I'm catching myself before it gets way into the problem. All right, I think that looks good. First step, what technique am I going to use? Well, what I notice right away is I have a cubed and not a squared. So if I can factor out an x out of all that, that'd be really nice, and I can. I can also factor out a 2. So I'll take out a 2x. 2x cubed divided by 2x is x squared. 10x squared divided by 10x is 5x. 2x divided by 2x is 1. Now, when things are multiplied together, how can you get 0? If one of them is 0. So if this is 0, when will 2x be 0? When x is 0. Or when this is 0. And when will that be 0? Don't know. It's a quadratic. Let's solve it. How do you want to solve the quadratic now? Try to factor it, but it doesn't. So let's do quad form. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, which gives me 5 plus or minus the square root of 21 all over 2. That doesn't reduce, so we're done. What's the answers? 0, and then that mess. Don't forget the 0. If you have a cubic, you will have 3 answers. If you have a quadratic, you'll have 2 answers, and so on. All right, letter D. This is one of those tricky ones. Notice it's an x and a square root of x. It is in the quadratic equation format. What do I mean by that? I mean that this term here is this term here squared. And so I can factor that thing. I can factor that into the square root of x times the square root of x. How do I know that? Because the square root of x times the square root of x is x. Whatever is here, that's what's going to go in my parentheses. Now, factors of 10 are 5 and 2. So I'll put a 5 here and a 2 here. I need those two to subtract to give me 3, so I need a negative and a positive. Next step, what will make each one of those equal to 0? Well, if the square root of x is equal to 5, that would work. And if the square root of x is equal to a negative 2, that would work. Well, the square root will never be negative, so that goes away. And so my answer is not that. So my answer starts off as the square root of x equals 5. If I square both sides, then x needs to be 25. And that's my answer. Okay? And this one didn't work. All right, I'm going to jump to F, because it's just like what we just did. Group all of these together and set it equal to 0. Is that in the form of a quadratic? Yes. How do I know? Because this term is the middle term squared. Or you could say the exponent of this one is half of the exponent of this one. That would work also. Either one of those tells me that this is in the form of a quadratic. Like x squared plus something x. This exponent is half of this exponent. Or this is this term squared. Either one of those concepts is what you want to ask yourself. So, factors of 6t to the fourth are 6t squared and 1t squared. Or 3t and 3t squared and 2t squared. Okay? I guess you could say technically that it could be this. Right? Because t to the third times t is t to the fourth. But I don't want to do that because I want t to the second power in the middle, and this here won't give me that. It'll give me a mess. All right. Factors of 5 are 5 and 1. I want those to subtract to give me 1 in the middle. But whatever I put out here gets multiplied by 6, and whatever I put in the middle here gets multiplied by 1. I know the 5 can't go in the far right spot, so it has to go here, and the 1 has to go here. I get 6 and 5. That does give me 1. I want a positive 6 and a negative 5, so I end up with 1t squared, because 6 minus 5 is 1. Okay? Next step. What will make each of these 0? When will 6t squared minus 5 equal 0? When 6t squared equals 5, when t squared equals 5 over 6, and so t equals plus and minus the square root of 5 over 6. But remember, we can't have a square root on the bottom, so t equals plus or minus, multiply top and bottom by the square root of 6, and so I get 30 on top, and I get 6 on the bottom. Okay? Over here, t squared has to equal a negative 1. And so t equals plus or minus the square root of a negative 1. And so t equals, by definition, plus or minus I. So there's my 4 answers. 2 here and 2 there. All right, jump back to E. So we have a quadratic, set it equals 0. So I have 2x squared plus 2x plus 3 equals 0. Let's check to see if that thing factors. And it doesn't look like it's going to. No, it doesn't. All right, so we have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Gives me negative 2 plus or minus the square root of 4 times 2 is 8. 8 times 3 is 24. 4 minus 24, a negative 20. I get negative 2 plus or minus. I know I need the square root of a negative. 20 can break into 4 and 5 all over 4. And so I get negative 2 plus or minus 2i square root of 5. Square root of a negative 1 is I. The square root of 4 is 2. That's all over 4. That breaks down into negative 1 plus or minus I square root of 5 all over 2, because 2 can go into all of them. All right. There's page 1. That was probably the longest page. Page 2. We have solving these inequalities, remember the goal. We're going to use a number line to help us, and we're going to put values for x that make the top 0, the bottom 0, or if I have factors, the values that make the factors 0. And then we're going to check each region for positive and negative sign. Okay? So, what makes the top 0? X equals a negative 4. What makes the bottom 0? A positive 1. Now, if I plug in something bigger than 1, like 3, 3 plus 4 is 7, so the top's positive. 3 minus 1 is positive, and so I get a positive out here. Hopefully, now that you've done this a bunch, you know it switches signs as it goes from one to the next. And there is a time when it doesn't, but we haven't addressed that in this class, and we're not going to do it. So I'll leave it that it does switch signs. Okay? So what do I want? I want to know where they are less than 0, where they're negative. When will my product be negative? Not when will the x values be negative, when will the product be negative? Between a negative 4 and 1. Now, this says less than or equal to. So, can I include both endpoints? No. The bottom can never be 0. So I can't include the 1. But I can include the negative 4 because that will make my equation 0. So my answer is between negative 4 and 1, including the negative 4, not including the 1. All right, letter B. That was nice. I gave it to you in factored form. So what are my factors solutions? X equals 2, x equals negative 3, x equals a positive 5. And I put them on my number line in correct order. Next, plug in a value for x that is to the far right. I always start to the right. It seems to be easiest. So I have this negative already out here. Now let's plug in 6. 6 minus 2 is positive. 6 plus 3 is positive. 6 minus 5 is positive. And 3 positives and 1 negative is actually negative. Then that goes positive, negative, positive. All right, what do I want? I want values that make my product, again, negative, but not equal to 0 this time. So negative. So between a negative 3 and 2, and between 5 and infinity. All right. Next one's not factored, so we have to factor it. So I have 2x and x. Factors of 6 are 3 and 2. So I won't put the sign in there yet. So I have 3 and 2. This gives me 4. This gives me 3. And 4 minus 3 does give me 1. How do I know I'm subtracting? Because that's negative. So I need a negative 1. So my 4 needs to be negative, and my 3 needs to be positive. All right. What makes this one 0? X equals a negative 3 over 2, which is a negative 1.5. And x equals 2 makes that 0. Okay. Next, on a number line, I have to slide over here. I put negative 1.5 and 2. Over here is positive, negative, positive. What do I want? I want values that are greater than 0 or equal to. So I go from a negative infinity to a negative 1.5, include the 1.5, and I go from 2 to infinity, and I include the 2 also. Okay, I have to get rid of this so I have more room. Next up, put on a number line values that make the top and the bottom 0. Just looking through, and I'll put them on in order. Negative 4, positive 1, positive 3. I am picking the pace up a little bit because we've done this a lot now. If this is not making sense, make sure you email me and ask. All right, next step. Plug in a value that is greater than 3, like 5. 5 minus 3 is positive. 5 minus 1 is positive. 5 plus 4 is positive. My answer out here is positive. And it will alternate signs as it cruises across. Sorry, I got way too close. Trying to save space. Negative 4, 1, and 3. Positive, negative, positive, negative. All right. What do I want? I want values for x that are less than, meaning negative. So less than 0 means negative. What do I want? I want things that are between 1 and 3 and less than or negative 4. I can't ever include the bottoms. What makes them 0? So I can't include the 1, and I can't include the negative 4. So I'm going to go from a negative infinity to a negative 4, not including it. And then I'm going to go from not including the 1, but I can include the 3. How come I'm including the 3? Because that'll make the top 0, and that's what I want, less than or equal to 0. Okay? All right, number 6. Sketch your graph. This is a exponential. My basic function is y equals 3 to the x. Okay, but I will go ahead and use the 3 to the x minus 2. What do I want to plug in? I want to plug in x values that are close to a negative 2. So how about, sorry, positive 2. So how about 0, 1, 2, 3, 4, and so on. If I put in 0, I get negative 2 as an exponent, and 3 to the negative second power is 1/9. If I put 1 in as the exponent, or for x, I get a negative 1 exponent, and I get 1/3. Putting in 2, I get 0 as an exponent, which is 1. Anything raised to 0 power is 1. Put in 3, I get 3 to the first, which is 3. Put in 4, I get 3 squared, which is 9. So at 2, it's 1. At 3, it's 3. At 4, it's 9. Going backwards, at 1, it's 1/3. At 0, it's 1/9, and it cruises along the x-axis, turns, and grows exponentially forever. Logarithm. Remember what our logarithm looks like. My first step, make a table. What am I going to make a table of? I'm going to ignore that minus 2 for a second. And I'm going to look at just the 4 to the y equals x. If that minus 2 is not there, I'm looking at just 4 to the y equals x. And I plug in my typical values, negative 2, negative 1, 0, 1, 2. If y is a negative 2, then this becomes 4 to the negative second power, which is 1/16. Then it's 1/4, then it's 1, then it's 4, then it's 16. Now, what does that minus 2 do to my table? It subtracts 2 from every y value, right? So now this is a negative 4, a negative 3, a negative 2, a negative 1, and a 0. This outside of the logarithm will move my graph down 2. Moving it down 2 is subtracting 2 from every y value. So when x is 1/16, y is a negative 4. When x is 1/4, y is a negative 3. When x is 1, y is a negative 2. When x is 4, y is a negative 1. When x is 16, way out there, y is 0. Comes up along the y-axis, curves, and it doesn't hit the x-axis until out there at 16. All right. Using the same logic, I said that minus 2 out here moves my graph down 2. So this plus 3 here moves my graph up 3. So I'm going to graph or make a table of y equals 2 to the x. Just y equals 2 to the x. When x is a negative 2, negative 1, 0, 1, 2. When x is a negative 2, 2 to the negative second power is 1/4, right? Whoops. That becomes 1/2 squared. All right, then we get 1/2. Hopefully you've done this enough where this is straightforward. So now here's what I'm going to do. I'm just going to start up 3. Normally, the graph of what I just wrote, the table I just wrote, has an asymptote at y equals 0, just like question 6. But now my graph is moved up 3, and I'm simply going to plot the points in my table from this shifted asymptote. So when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4, up from the asymptote. When x is negative 1, y is a half, negative 2 is a fourth, and I get that curve there. Okay, this here moves my graph to the left 3. I'll make the same table as I had above. I'm looking at just y equals log base 3 of x. Forget the plus 3 for a second. I'm going to make a table of 3 to the y equals x. Okay, I'm going to get rid of this so I can see my table better. So now I have numbers plugged in for y. Negative 2, negative 1, 0, 1, 2. If y is a negative 2, then x is 1/9. If y is a negative 1, then x is 1/3. If y is 0, it's 1, then 3, then 9. When y is 0, x is 1. So now, this moves my graph left 3. So I'm going to start at an asymptote of negative. Kind of missed my asymptote there, didn't I? Has an asymptote at negative 3. Okay? Now, from there, I'm going right 1/9 and down 2. Right 1/9, down 2. Right 1/3 and down 1. Right 1 and up 0. Right 3 and up 1. To the right 9 and up 2. And my graph comes along the asymptote, curves. Wow. I have a big pen. It's hard to write. Comes along the asymptote, curves, and passes through my points. I missed by a little bit. Okay? If that didn't make sense, go back to the graphing of the logarithms and check that out. If that still doesn't make sense, email me, and we'll see how it goes. How long is this getting to be? I might split it right here. Let me finish this page and then we'll split it. All right. Write in logarithmic form. So we kind of just did something kind of like that up here. We did question 11 on question 9 and question 8. So let's do that one first. Write in exponential form my base and my exponent. So I write that as 7 to the 4th equals x. My base, my exponent. Okay, let's go backwards. The answer to the logarithm is the exponent. So I know the x is out here. The base of the exponential is the base of my logarithm. And what am I taking the log of? 10. Now, for most people, that's the hardest part. Question 10, going from exponent form to log, it's harder than going from log to exponential. But when you're done and you have your log, just double check. 7 to the x equals 10. Perfect, we did it right. But if you talk through it like I did, the answer to my logarithm is my exponent. The base of the log is the base of the exponential. And there's only one spot left for the 10 to go. All right, simplify. We're going to use the exact same thought process as we just did in 10 and 11 to help me solve this. So log, let's start from inside. Log of 81 base 3. What question is that asking? Question 11. Switch forms. It is asking 3 to what power equals 81? 3 times 3 is 9, times 3 is 27, times 3 is 81. 4. The inside, or the answer to this, is 4. So now I have log base 2 of 4. What question is that asking? 2 to what power equals 4? 2, because 2 squared is 4. And there's my answer. Question B, 25 raised to what power equals 5? Well, I know 5 squared is 25. How do I go backwards and get a 25 to be a 5? I raise it to the 1/2 power. I square root it. Remember a 1/2 exponent means square root? Not negative. Some of you might be thinking, oh, it's a -2. No, that's 1/25 squared. That's not right. That's 1/625. Okay? So it's 1/2 exponent. All right, we'll stop with that. We'll do the next 2 pages, 3 pages on the next recording.